This conference will now be recorded.
Hey, once again, thanks everyone for joining. And my name is Adam. And in this session, what we are going to understand typically is what is the meaning of container orchestration, right? Because from the last two sessions, if you see, we first understood what exactly is Docker, and in Docker, what do you mean by container management and then image management. And following that, we are now going to see what's the third part in Docker, which is called as orchestration. Now, in that, we'll be going through a tool called Swarm, and then using the Swarm, how is that we will be able to create a cluster? How is that you are going to manage it? And we'll also have some of the advanced topics like config and health check. Okay, so typically this is the agenda on what we will be trying to do in this session. Now, again, before I start, I would request everyone to subscribe and share the channel. All right, now, as we are talking about orchestration, let us first understand what is the problem that we are going to face if we are using the regular Docker daemon, which means now for your development or any kind of smokes test, we saw that we would be able to use compose and create multiple containers on the same machine. So that's well and good for development. But as we move on to an actual QA environment or a perf environment or a beta or a UAT or a production environment, now we will be having many containers to be created. So let's say I have a machine in which I have installed Docker and the Docker daemon is running and it has a capacity, let's say 12 GB of RAM, for example. Now, in this, if I create a container, let's assume that the container or the application in the container would require around 4 GB. So now, if I have a requirement of creating 3 containers for my work, then it will not be possible that I can exceed the amount that is available, because going back to the basics of the Docker, the daemon will be using whatever is available on the host machine. So that way, the max, if you see, I would be able to create is around 2 container, because on the host machine, the OS of the host might take some RAM and there might be some other applications or services running. So that is where you will not be able to have another container on the same machine. So what is that we will do for this? Now, in order for us to create another container, definitely we have to go with another machine in which, again, you're going to install a Docker, and then whatever the communication you have to do, you will have to go to this machine and execute the Docker command, which will be communicating to the Docker daemon. So that is how, for creating 3 containers in this example, you have to typically go to each machine and create containers separately. Okay. Now, like this, as we move up in the SDLC from QA to production, there might be many machines available, right? And then in each of the machine, we are going to install the Docker separately, and there will be a Docker daemon running. So now, let's assume this is a scenario in which I want not 3 containers, but for my work, I want 5 copies of my application, which is nothing but 5 containers based on the same image. So how is that you're going to create? So now, if I give you 4 machines, and if I'm asking you to create 5 container, then typically what we have to do is first see how many machines we have, and in that machine, what is the capacity available in each machine, and based on the available capacity and how much that you need for creating a container, you need to do some math and then say, okay, looks like this machine is full and I have the remaining machines, and based on this I will be able to create. So that way, for you to create your containers, you need to go through all the machines, which is nothing but typically you have to connect to every machine, gather the information of the resource availability, and then you need to do a math on how much is the containers you need, and for that, what is the total amount of resources. So based on that, you will be creating. So let's say now in that way, I saw that I already have 3 containers. So then I created a container here and a container here. So this way, Every time, if you want to create a container among a group of machines, first you need to see which machine is available, and in that machine, how much of resources is available for you to create a container. Because let's say there is a machine available, but there will be no enough resource for you to create a container. In that way, you have to again go to the next available machine. So this is how every machine that you have in the group, you need to keep connecting and verifying. Okay, now like this, if I say again I want another container, what will you do? Once again, you need to go and check all the machines, which machine is available and which machine has the enough capacity for you to create your container. So this is the biggest headache that you're going to have. It sounds easy, but assume when you have hundreds of machines, how is that you're going to manage? So you cannot keep connecting to every machine, right? This is one of the problem that we have. Because if you want to create a container on a machine, we need to go to that machine and use the Docker Compose or Docker client, whatever it is, but it is going to communicate to that daemon only. Because from one machine, I cannot create another container available on a different machine unless and until I don't communicate to it. So that is the problem that we are trying to address. Now, let's say you wanted 6 containers and it has been created among 4 machines. Now, is that what you need? Yes. So what I need is 6 containers. But what happens now suddenly if one of the machine goes down? Now, because of that, whatever the containers is available will also go. Now what happens? For you to do some work, you needed 6 containers. Now, you created first by finding out what is the availability in each machine. But suddenly when something goes wrong, again, you should be monitoring. So that is where very frequently I need to monitor every machine, keep a calculation of how many containers is running, how many that I wanted, is it perfect? So that way, if something is not working, then you need to replace. So now if you have to replace these 2 containers, what you have to do? Again, you have to go and check for all the machines available, and in that you need to again do the same math and then create. So that way, probably you might create 2 here. So this is how every time that you want to create a container, you need to go through all the machines and you need to monitor, right? Because it's not just sufficient for us to create. Because for me, it's not about creating, but to make sure whatever that number of containers I need, it should be always available, right? So that's when, again, when this machine comes up, you need to add to your pool so that if any other requirement comes, you can say that, okay, let me go and connect to this. So again, this will be a problem for you. Adding a machine or removing a machine will be a total disaster. Okay. Now, just in case, if it is not the machine, let's assume you wanted 6 containers. 6 containers are running, but for some reason, in one of the container, application is not working proper. Okay, because of various reasons that we can find. Now, because let's say that there is some configuration problem or a network issue or some storage issue. Now, because of all these things, what you wanted is 6 containers. Sometimes 6 containers may be running, but out of that, one of the application might not be running inside the container properly. Then how will you know? Once again, what you have to do is you have to do a monitoring where not just the number of containers, but inside each container, whether your application is running properly or not. So that is something, again, you have to start monitoring. So this is where we are going to face huge problem. So now, typically, as we have more and more machines across which we are going to have many containers, it's not easy for us to manage because I cannot keep going or connecting to each machine and then create or manage containers. So this is one problem. Now, like I said, if one of the container is not working, then my requirement is if I wanted 6 container, then I should be able to quickly replace once again. Now, if I say replacing, then you have to go back to the same initial problem where you need to find how many machines you have, in that which machine is available or resources there. Again, you need to find out and create container. Okay. Now, on the other side, when I have multiple containers of same type, let's say that I created a Nginx server or a Tomcat server, then all of them are of the same type. And then when on a particular machine, if I want to create more than one container, then the problem comes is port mapping, right? So let's say if I have Tomcat is giving me 8080, then how can I have two containers mapped to the same 8080 on the host machine? That is one problem. Then when you are creating a container, every time you have to find out and keep changing the port numbers. Okay, that is a problem. Now, what if I want to do the load balance of this? Then when you are trying to do a load balancing by an external load balancer, the load balancer will just map to a particular port available in the machine. So that way, it will be going only to the machine level. It will not be able to reach you to the containers inside it. Because when I have more than one container, how can I use load balancer not just to come to the machine, but also to the particular containers here? So that's where all these things are not possible if you have your regular daemon running, which is one machine, and in that one installation of Docker or daemon available. Okay, so that's when, until your development environment, you can have a single machine in which Docker daemon can be installed, and using the Docker client or the Docker compose, you will be able to create one containers or multiple containers. But whenever as we move ahead for QA or stage or production, then we will have multiple machines and we want to create multiple containers. So that's where we introduce a concept called orchestration. Okay, so typically whatever that we are trying to do, right? So rather than we going to each of the machine in which Docker daemon is running separately and communicating to it, finding out whether your container is running or not running, and then tell it to create a container or delete a container, right? Then all those things, rather than we going to each machine, if we can do it in a better way, that's what we call it as orchestration. Okay, so when does orchestration come into the picture? Whenever we are going to have multiple machines in which each one of them has a separate Docker daemon running, and when you want to collaboratively manage all these machines, then what we need is orchestration. So this way, by doing a orchestration on container, what is that we will be able to get is health check, so that now you don't have to worry, because you can make sure that whatever the container that you are starting, we are not going to just check only whether the container is running, but we can also make sure whether my container is healthy, which in the sense inside the container whether I have my application running fine or not. So that's what we can do using orchestration. Then at any point of time, if I say that I want 6 containers or 10 containers or 20 containers, we will make sure through the orchestration we will always have the same number of containers, so that if any one of the container goes down, we should be able to automatically replace it. Okay, and if I want to increase more number of containers or decrease, then we should be able to do, because rather than we going to each machine, we should be using a orchestration system wherein that should be able to do all the work for us, so that our time should be only to managing it rather than we going into each of the machine. So that's where using the orchestration system, we will be able to make sure if I want suddenly from 6 containers to 20 containers, we should say, but which machine is available and in which machine how many containers can be created, that should be what the orchestration system should do. So we should be just telling how many containers that you need. Okay, then we should be able to do rolling update. Now what do you mean by rolling update? So let's assume first we took one image and created 6 containers, and that is scattered across different machines. Now as I'm doing testing, I created a new image. Now I want to replace those old images with new images, which means those old 6 containers should be replaced with my new 6 containers based on the new image. So in that way, if I ask you to do it manually, this is where you not find out by going into each of the machine and stop it and then bring it up, correct? That could be again a tedious process for us. So that's where we should have a better way in which, hey, there are 6 containers running, just replace them with the new one. And for that, what are the properties you should be able to do? Such a kind of system is what we call it as orchestration. Okay. And not just that, the last part is the load balancing. So rather than thinking about load balancing to the machine, we should be able to load balance across the containers. So that now if I say 6 containers, if I try to access, orchestration system should help us to distribute the load between the containers, not the machine. Because sometimes in the same machine, you can have multiple containers. Then it should be distributing the load between the containers, whether it is on a single machine or multiple machine. So these are the requirements why we need to do a management of multiple machines and multiple Docker daemons running in it, which is what we call it as container orchestration. Okay, so that's when, if you go back to the basics of Docker in our previous sessions, we understood container is the concept and Docker is one of the tool using which we will be able to create or manage containers. The same way, we have a lot of tools available in the market to manage the orchestration. Now, quite 2 of them are popular. One is Docker Swarm, the other one is Kubernetes. So in this session, we'll focus more about Docker Swarm, which is exactly similar to how Kubernetes will be working. So in that way, Swarm is actually, if you understand, is part of your Docker. See, unlike Kubernetes, Swarm is something which comes by default along with your Docker daemon. So that means if you install Docker daemon in a machine, by default, Swarm is available in it, but it will be disabled. So that way, what do you mean by Swarm? So Swarm is nothing but, it is kind of a technique where we connect multiple machines in which Docker daemon is running, so that we will be able to create as a cluster and whatever the management for the containers we can do through that cluster. So instead of we going to each machine and communicating or managing the containers creation or stopping, what we can now do is we can try to create a cluster wherein we can put how many ever machines that we want in the cluster, and using this cluster we will be able to do the orchestration. Okay, now this is something like WhatsApp. Now by default, WhatsApp may be available in your mobile, but only when you enable it you will be able to use. So that way, by default, when we install Docker, you will be having the Swarm, but it will be in a disabled mode. Okay, again, when you say WhatsApp, typically when you have larger groups, it's not good that you will be able to communicate, or you don't want everyone to be sending unnecessary messages. So the same way, now when I'm talking about container management, now I want 6 containers. So that is what I am going to tell. So if I have to tell, again, from where I have to tell, so that is where what you will do is, we will have something called as a common machine, which is called as manager machine. Okay, wherein instead of we going to each machine and telling, you can just tell that to this particular machine or to this particular machine in which you have created the cluster, and this will communicate to all the machines. So that is where orchestration means we will create cluster of machines, or we will take individual machines in which Docker daemon is running and connect to a group or a cluster, and then whatever we want to communicate, we will communicate to one machine in which the cluster or the group is created, and that will communicate to all the machines which has been added in the group or the cluster. So that way, this cluster is what we call it as Swarm. Okay, so in general, Swarm is nothing but a mode in which you can add multiple machines as a group or a cluster. So that is what I said initially. every Docker that you install or a Docker daemon will be running on a standalone mode, which means it cannot have a capacity or ability to connect to between two machines. Whereas now, if you want to work in the cluster mode, you can enable the SWAM so that the machines can connect to each other through a cluster. And in that, we are going to do all the communications through a machine. Okay, so this is how we are going to work. So that way, SWAM is nothing but a group of machines in which Docker daemon is running separately. And instead of going to each machine, you can just communicate everything through one machine. That is what we call it as orchestration. All right. Now, in the orchestration, what is that we are going to actually do is define something as a service. Because let's go back to our Docker Compose session. Whenever you have more than one container to create, we saw that we are going to define something as a service, correct? Wherein service is nothing but how many containers you need and what image you are going to use, what port you need, and then what particular volumes that you can use or any other configurations that you need, right? In the same way, in the SWAM mode or in the cluster mode, if you want to create, like I said in the previous slide, I want 6 containers, then what you're going to tell us, you're going to define what is that you need to the first machine or the machine from which you are going to manage, and the SWAM will then make sure what are the machines available, and in that machine how much of capacity or resources available. Based on that, it will try to create the containers. So that is where now if I say, okay, I want 3 containers, then you are going to define the state as I need 3 containers, and for that what machine is available and in that how many containers can be created will be taken care by the SWAM or the SWAM cluster. And in that, it is not just going to check, but it will also start monitoring. Okay, so we'll talk about it a little deeper. So now what we need to know is, instead of executing the Docker client commands, which was communicating only on one machine, now we can connect multiple Docker or multiple machines in which Docker daemon is running as a cluster, and we can communicate from one machine, and it can reach and it will take care of creating or managing or deleting the containers. Okay, and that kind of work in which we are connected to multiple machines is what we call it as a SWAM cluster. Okay, which is nothing but group of machines. So before we jump in a little deeper onto the commands, let's quickly understand some of the components which is available, because that will be very helpful. Okay, so again, we will be seeing the diagram. Guys, please mute. Okay. I think someone. Okay, I've just muted the person. So now you will be seeing this diagram a lot, so get used to it. So once again, now you can see that it's nothing but a cluster in which we have 5 machines in it. Now in this, when you take a cluster, every machine in the cluster is typically called as a node. So that node is nothing but in your SWAM or in your group of machines, every machine in which Docker is installed and it is connected as a group is called as node. Okay, so in this there are 5 nodes. Then when you connect these 5 machines together to interact and then as a cluster, then that is what we call it as a SWAM mode. So that now as you connect to everything, if you look, the SWAM mode will be enabled in all of them. Or in other way, by enabling the SWAM mode, we will be able to communicate to all the machines. Okay, now the important thing, like I was telling you in the previous slide, is service. So now instead of we going to all the machines, typically we will be choosing one of the machine and you're going to define the state. So state is nothing but what exactly you need. Okay, so that is what we call it as a service. So now what is that you need? You're going to define it as a service. And in the service, what you will be telling is what image to use, how many containers that you're going to use, and in that containers, is there a specific command to run? And again, for that service, what port or volume or network that you have to use. So all those things you're going to define. Okay, and then the SWAM mode will make sure that you have the respective containers created across all the machines. Okay, that is what we call it as the service. Now, however, what services does is creates container in the respective machine, and that is what we call it as a task. So in the other way, you define what is the service you need, and inside the service, whatever that you're telling as a container and the command that you want to run, that is what we call it as a task. So that once you tell the SWAM that what is the service you need, based on that, whatever the task it has to do, it will start doing it on the machines available, and it will monitor the tasks. Okay, so that way tasks are nothing but containers, and in that what you want to run. So that is how service will know, okay, you told me that you need one service, and for that service I have 6 replicas or the 6 copies of task. So I need to make sure that those tasks are always running. So that is where if any one of the container goes down, the service will know that there looks like a replica or a task which is not working, and then it has to take necessary action for that. Okay, then when we talk about this group, I was telling you this, that when you will just go to one of the machine, and this is where you are going to communicate. So that way, in SWAM or in the SWAM mode or cluster mode, we typically can segregate all the machines into 2 types. Okay, so the first type of machine is what we call it as a manager machine. Okay, now ideally, whatever the work that we want to get it done, we are going to get it done through manager, or whatever the communication we are going to do, we are going to do only to the manager. Okay, wherein if I need 6 containers with whatever port and volume, I am going to define it as a service, and that service you are going to tell it to the manager. So that way, manager is responsible for understanding your service, and in the SWAM mode, the manager will try to find out how many machines you have in the cluster, and at that time which is available, how much of resources there, and for your service what are the tasks it has to do. It will try to create the containers, and it will start monitoring. Okay, so that is where we are not going to each machine, we are going to create a group, and we are going to communicate to one machine, which is what we call it as manager. And the manager will make sure that how many other machines are available in the group, it will be communicating to that, and based on the need, it will be creating the tasks or containers, and it will monitor them. Okay, so that is how our work will be easy, just like an organization. So if you have an organization in which, now you can see every team will have a manager, and under them there will be certain people working. So now if there is a management person wants to give some work or allocate, then typically they will not be going to each individual. So there will be always a manager or a manager's manager. They will be communicating to them saying that, hey, this is the work I want to get it done. Then the manager will find out, okay, in my team I have 4 people. Out of 4 people, looks like one guy is already occupied with some other work, and I have remaining 3 people. Okay, probably with them I can get this task done. So that is how the regular management, whatever you are going to do in your day-to-day work, the same way in a cluster, only to the manager machine we communicate and we tell what we need as a service, and the manager machine will try to manage on how many containers to create, where the availability is there, and it will create. Okay, so that way, now the remaining machines in which the containers are actually created or the containers will be running is what we call it as worker. Okay, so it's very simple. In a cluster, now when you create machines, you need to first separate it in such a way that which is your manager machine from which you want to communicate, and then what are the remaining worker machines in which the manager should tell how many containers to create, what to create, and monitor it, and if something goes wrong it should recreate. So all those things will be done by the manager. So that's how you will be having two types. One is manager and then worker. Okay, and our communication happens only to manager, and manager will try to communicate to the worker machines and take care of the orchestration. Now, with this, let us try to see how we can create a cluster and how do we manage it, and then we will also see how I can specify what is manager, what is worker. Okay, now as I said in the beginning, by default in any machine that you have installed Docker, in that it will be running on a standalone mode and the swarm mode will be disabled. So we need to create a cluster. Okay, so for this practice or the demo, I've already created some 4 machines. Okay, so let me just take these 4 machines now. So this is the first machine. Now in the first machine, to check whether Docker is running, because what I have done is to save time, I have pre-installed Docker. So Docker is running. Now in the Docker info, just go ahead and grep for swarm. You can see that it says inactive. That means this particular daemon is running on a standalone mode. Okay, so it cannot communicate to anywhere else. So that way, all the 4 machines or any machines that you have will be by default running on the disabled mode of swarm. Okay, so like that, let me quickly connect to all the other 4 machines. So this is the second machine. Once again, Docker info, I have already installed Docker in it, but let's check swarm. Here also it's inactive. Fine. Now let me connect to third machine.
Yeah, Docker has to be installed on all machines.
Yes.
Okay.
Because if you go back to the diagram, in each and every machine, Docker needs to be installed. It's just like WhatsApp. If I have to communicate with you, then even you have to install WhatsApp, right? Then we creating a group and then we will join. The same logic is also what we are going to do here. Okay, so that way I'm not just showing you to install Docker, but yes, each of the machines is going to be connected as a swarm cluster, which is nothing but connected through the Docker running in them. Okay, so that's where I'm just quickly trying to show you. So here also I have, so let me connect to my 4th machine. Okay. Okay, for some reason it's not copy pasting. Let me open another command prompt. Okay, so you can ignore this one, but typically on others we have 4 machines. Okay, so now just like WhatsApp, if you want to communicate, first you need to install WhatsApp on all the machine or on your mobile. I'm talking about the same way here. If you want to start with your swarm, first install Docker separately on all the machines and it should be running. Then in the WhatsApp, any one of the person who is going to be act as the admin will create the group, and then he will share that particular, the group's link or the token with others, so that from there mobile on their particular WhatsApp application, if they click on join, it will be connected to the group, right? The same way, now you need to take your first machine, and in that machine, if you execute this command called docker swarm init, then a group will be created and it starts from that machine. And the machine in which you are going to run that will be considered as the default manager. Okay, so now I'm going to run on that. So you can see here on this machine, I have basically created a group, but I haven't added any machine so far. But the machine in which I run this is considered as the manager. So going forward, any communication I want to do, I will be doing with my first machine. Okay, and then here you can see that it is trying to give me a command which says join, which is nothing but this command is what I am going to run on any other machine which is available in my network in which Docker is installed. It's just like your WhatsApp. I created a group. Now I'm sharing this group to you. So you have to go to your WhatsApp and then click on this so that you will be joining to the group, right? The same way, all you have to do is go to each machine in which the daemon is running, and you can see it says it connected to your group, whatever you have created, and the token is this. Okay, and see what is it saying. It's joined as a worker. Okay, because just like your WhatsApp group, if you join, by default you will not be the admin of the group. Okay, you will be just a participant. The same way over here. Now I can go on and add to whatever machine that I have. So now typically, like I showed you in this diagram, I'm going to have 4 machines which are worker machines, and then by default there is one manager in it. Okay, so now if you see, there's totally 4, and 1 is manager and the remaining 3 are worker. So one thing what you need to know is, suppose if you are using a AWS machine for creating this, and then here you can see the Docker daemon from one machine to another machine, it is going to communicate using this port, because this is the IP address of my current machine in which I have installed the group or enabled the swarm, so that the other machine should be able to communicate. So make sure that in your inbound rule you are allowing 2377, which is something I've already done on the security group. Okay, so that's something as a beginning. And now here, now if I go back and say docker info and swarm, you can see it says it is active. The same thing if you go back to all the other machines, you can see it's active. It's active, right? So typically in all the machines it is going to be active. All right, now what we have done, just like WhatsApp, we have made sure that in all the machines we have added. Okay, so this way now we have a cluster, or technically we are going to call it as, we are having a swarm cluster in which we have 1 manager and 3 workers, so that going forward, wherever you did the first Docker swarm in it, that machine is called as the manager, and going forward, whatever the service you are going to create or monitor, you are going to do from this machine, and this machine will be communicating to all the other machines. Okay, so this is just a simple way of creating a swarm.
I have a question here.
Now, to see
Hello.
what is the details that we have, okay, like in our case, I have typically total of 4 machines, and in that 4 machines, I have 1 manager and 3 workers. So we will also see as we move forward how I can create more than 1 manager, how do you shuffle, all those things we will see. But first, let's understand how this is set up and how it is going to work. Okay, we will be talking
Madam?
about all the components one by one. Please make a note of your questions, what you have. I'll be talking about all the topics, whatever that you're thinking of as we move on. Okay, if in case is there something that I'm missing, please make a note. I will be discussing it a little later. I appreciate that. Now if you go to your manager machine, and okay, now going forward, I don't have to communicate to all the machine, because this is the only machine that I need, in which whatever I need I'm going to tell as a service, and this will be taking care of communicating to the rest of the machine. Okay, so that way the first thing what you're going to do is use the same Docker command, but now understand the daemon on this machine is not running on a standalone mode, it is running on a swarm mode, so that whatever commands that we are going to see today will work only on a swarm mode. Okay, because with just one Docker daemon running in the standalone mode, if you try to run any of these commands, it will not run, because that's different. Whereas here we have created a swarm, as you can see that in the previous output of Docker info, we saw that it is now active, which is nothing but swarm is active. So now here, if I go ahead and say node ls, it is going to show you all the machines available in your group, just like in your WhatsApp. If you go and say how many members are there, same way. Okay, so now you can see in our cluster or group, or this is what we call it a swarm, we typically have 4 machines. Okay, and all the 4 machines are active. So there is a specific meaning for each and everything. We will be going through all of them slowly. Okay, so first, now it should be clear to you that how we are going to create a manager, and from there you take the token and go to all the other machines and keep adding it, so that this one machine what you have will be acting as the manager, and all the other machines by default will be acting as worker. Okay, now with this setup, what we are going to do now is define the service. So this is how, rather than saying I need one container separately or multiple containers line by line, now we are going to define as a service, and then we will be able to specify that to the manager machine. When you are using this logic of more than one container, then we can define anything that I need to a swarm either in command line, okay, or through a file, which is what we call it as declarative method. Okay, now we will see both of them, but just to start with, to keep everything easier to understand, what we will be doing is all of them we will be running it from a imperative method. Imperative means we are trying to give everything through command. The same thing we can also use a file. Again, it's the same file what we saw in the Docker Compose. So we can use a YAML file called Docker Compose YAML file, and whatever that you are going to give on the command line, you can give through a file and then tell the swarm to read from that. So that method is what we call it as declarative. But anyway, before we go to that, let's understand the concept here. So now, if you want to create a service wherein what is that you need in terms of how many containers, and then what image to use, and for that what are the other properties or configuration, you're going to say Docker service create, and then a name for your service, just like again in the compose file we had given, right, in the Docker Compose, the same way. And then for that, replicas are nothing but how many copies of the container that you need. And then if you have any kind of port mapping, then you're going to say your container port and host port, and followed by what image are you going to use for creating this service. Okay, so one of the example that I've given here is I can just say Docker service create, and I'm going to take a Nginx image, and the name of the service I'm creating is web. And since I have a Nginx, it will be running on port 80. So I want to map it to port 80 on my host machine. Okay, so let's start with this. So once again, all I need to do is go to the manager machine. Okay, and then execute this command. So now in a service, if you do not tell the number of containers that you need, then by default it is one container, because a service cannot be created without a container. So that way the minimum number of containers that we are going to create by default is 1. However, we can see how we can tell more containers that we want to create. So here in the manager, we created a service, and by service, we are telling that, hey, I need to have something called as web, in which use the Nginx image and create one container, and that container should have a port mapping of 8080. So that is what we have told. So how do I now see what is the service created or not? So that's where we are going to use a command called docker service ls. Okay, so ls means list all the service. Once again, all these things will be running only if you have the swarm mode enabled. Okay, so let's go back, and now if you run service ls, you can see it is saying there is a name for the service called web, and that is having one container by default, and one by one now represents that the swarm has started monitoring, so that what you wanted is one container, and how many container in the cluster it is running is one. So that way, whatever is your desired state that you have defined is available. Okay, so that is how you can cross check what is the service availability. Again, what we are doing here is we are just seeing whether the service is created or not, what is the property. But in this, if I want to now know where is the container created, because if you understand, this is where in a swarm mode or in the orchestration, we will not be worrying about where the container is created. All I need is I want one container. So that way I have 4 machines available. In that, the swarm's duty is to make sure that whatever machine is available, in that it is going to create the container for us. So that is where it is the flexibility we are going to have. So that way, now if you want to get the details about what exactly is happening to the service and where is the service running, or what do you mean by service now, number of containers, what you have to do is you have to say docker service ps, because what does ps stands for? If you go back to our Docker basics, it will show the number of containers, right? So that way, for this service, how many containers are running and where it is running, and that details, whether it is running or not, you will get that also. So that's where the command that you're going to use is docker service ps and the name of your service, that is web. So you can see now it's saying that there is one container running, and that container is based on Nginx latest, and where is it running? So that is where you can see it is running on this particular machine, because this is the machine that where you are working. Okay, ideally what happened now, it is running on the same machine called as master or the manager machine. Okay, so you told one, so now it found out that there is a machine available on which you are working itself has resources, so it went ahead and created. Okay, so now let's see, if I want to create more containers, how it will be able to manage. So that is where, if there is already a service and that service has a property defined, if you want to scale that, because in my case I already have a service called web which has one container, now I want to just add another container. This is where, see the flexibility of orchestration. All you are going to tell is update this service by saying that what you need is not one container, is 2 containers. In that, the swarm's duty is to find out what is the machine available and create a container. And for creating a container, what and all it is going to take, that is what you have already defined as a service. So it will recreate, or it's not the right word, it should be creating a new container which is again based on Nginx latest, and that also will have a port mapping of 8080. So whatever is the properties that you're having for this particular service, it will just make a copy. That is why we call it as replica. Okay, so it's going to be very easy for us using swarm. So how do I do that? So for that, you're going to say docker service, the name of the service, and then scale it and give the number. So that way, now this is a service which is already available, right? Now watch this. If I say Docker service scale and the name of the service, and I'm saying 3, okay, out of 3, 1 is already available, so that is where it is just quickly trying to create remaining 2. So that way each container is called as a task. So what we have told internally is the service will know that, okay, earlier I had 1 task, now you are asking me to do 3 tasks. So Swarm will be just adding the configuration on top of what we have given. So now if I do a ls, you can see what you have requested is for 3 copies or replica, and it has internally created 3. And now if you want to see where it is running, you can go ahead and say now Docker service ps and the name of the service. Okay, you can see now each one of them has been selected on a different machine. So this is how you don't have to worry. You create a group in which you will have enough number of machines, and how many ever containers you want to create, you are going to define it as a service, and the Swarm will make sure that in the cluster where is the resource available, based on that it is going to automatically create it. Okay, so this is how any point of time I can scale up or scale down. See, let's say suddenly I don't want 3, I want 2. Now if you have to do it manually, you need to go to any one of the machine, or even before that you need to first find out where exactly it is running, and from that one container you have to stop. Instead of that, when you say 2, automatically what Swarm will do is it will pick up, okay, I have 3, let me take one random, and it is going to bring it down. So that's where now if you look at the service, it has updated its state, wherein what you needed is now 2. And for that, if you do a ps, you can see automatically it is going to manage. So that's how it will be very easy for us to scale up and scale down. So you don't have to keep going to every machine. Okay, you just define as a service or update the service. Swarm will take care of the remaining things on whether to bring the state, whether it has to create more containers or remove containers. Okay, the same logic, if I want to delete it everything, once again I don't have to go to each machine and stop, because I don't have to worry or know that where is the container running, because for me all I need is 2 containers currently, so it should be running. And now if I want to delete, all you have to say is service delete. So if you delete the service, what will happen? It is going to delete entirely. Okay, but before that, if you want to see the properties of what exactly is happening in the service, then you can go ahead and say Docker service inspect. So that is where you can inspect a service, or you can inspect a container also. So inspect is nothing but a command which is going to give you all the properties about that. So in that way, by default, if you say inspect, it will give you a JSON format. So it will not be very easy to look. So to have a pretty much aesthetic look, you can add pretty and then the service name. Okay. So if I go to manager, and in the manager, if you say pretty and name of the service, you can see it gives you again in a YAML format, in which it's going to give you the properties about that. Okay, same way. Now when you say Docker service ps and the name of the service, whatever that you are getting is not the container ID. Okay, so remember, this is the ID of the task, because for this service we have 2 tasks. Okay, so these are nothing but the task ID. So that is where if you want to know what is the exact container ID or the details about the container, then go ahead and first do a Docker inspect and this ID. Okay, and if you just enter, you will be seeing pretty much all the details about that task. In that also clearly you can say what is the state, where it is running, and what is the container ID. So for example, if I want to take the container ID of each one of them, then the simple way of doing it is Docker inspect, and you can say the service name, and container ID. Okay, let me just take this. This is the container ID. Same way, if I want to get others, now we also have another option called format, but I'm not just going in deeper of that. That's your regular command. But if you have, that will fetch you only particular output. But again, it's just a simple way of getting. So this is how the Docker service will give you all the tasks. So that is where this is called as the task. So we have two tasks, and this is the task ID. And when you say Docker inspect the task ID, from that you will be able to get the details of container. Okay. And now if I go to this machine, I'll be able to see this particular container running. Now let's say I will take this one. Okay. Now this is running on a machine called 104. So now I don't know which one is 104. Okay, pretty much. Let's see. Yeah, this is the one. So now if I say Docker PS, you can see. And this way you can see here, the container ID is matching. Same way, I can do a Docker inspect of this container, and it will give you a whole bunch of information that you need for that. Okay, so that's where you will be able to use the Docker service ls and service ps and the name of the service to see what is happening, and in that where it is running, and get the properties using Docker inspect. Because in some time, if it is not running, then you can do a Docker service ps and the name of the service and try to find out what is the state by getting the properties or inspect, and then find out what exactly is happening. Okay, so finally, now if I want to delete a service, then simply say Docker service rm and the name of your service. So here, if I want to delete, you can see I will say rm and the name. It is just going to delete the service. So that's where it's super fast for us. I don't have to worry about finding out where the container is running and delete. Instead, I can simply say here delete the service, and whatever is internally available for that, it's going to delete that also. Okay, so this is what we call it as service, wherein how we can create a service, start it, right, and typically run containers and delete it. Okay, again in this, if you note, we are not telling anything other than just telling the state, wherein where it has to create, whether it is running or not running, all those things will be taken care by the SWAM. Now as we move on, we will see further other scenarios on how do we handle, but until now it should be clear that how SWAM is helping us in creating containers wherein we don't have to tell which machine, and in that the SWAM will just take the service state, and from the state it will be able to help us in creating the container. Clear so far?
This conference will now be recorded.
So now we understood that a simple cluster and what you have to define to a SWAM is a service. But how do you basically differentiate between a manager and worker? And how is that we identify or designate whether a machine should be a manager or worker? Because what happens in real time is you cannot always have the same machine working as manager, correct? Because as we move on, if that machine goes down, we should be able to bring a replacement for that. And that's where we need to understand on the manager and the worker states. Okay, so this is when you add a machine to a cluster, it will be trying to give us the status, right? So let me show you that little later, but try to understand it. So when you do a Docker node ls, it will be trying to give the status. Now in that, in a cluster, if a machine doesn't have the status of it, then typically it is called as worker. Okay, so if you just remember in the last slide or the the beginning, I was trying to show you, so that now if you see that it's a blank, then it's going to be called as worker, or it doesn't have any properties by default. However, if the machine is a manager machine from which you will be able to communicate, then that machine is actually called as leader. So the meaning of leader is, so this is the machine which has the ability to communicate to all the other machine, monitor what exactly you wanted, and take care of what the state of the service that you have asked. Okay, so that way, in any point of time, in a particular cluster, there can be many workers, but there will be only one leader. Like how you have an organization, in a team, there will be only one manager, right? And all the other people will be a regular employees. The same way, remember, leader is the machine in which you are going to communicate, and that has the ability to communicate further to all the workers. But what happens, like I said earlier, sometimes if, let's say that in your company, in the team, if your manager is absent, then how is everything going to be managed? So that is where obviously you will be having the next person who will be in the hierarchy, like a lead or a senior, so that he's not a manager in your company, but he's going to be someone like a acting manager whenever your actual manager is not available, right? So that is where you're going to actually give a name like a lead or a senior, whoever it is. Now, typically, how will that happen? So that's where they will have to promote them, correct? So the same way, in a group, there will be only one leader. However, at any point of time, we can take up any worker machine and we can promote it to become a manager. But the difference, that is where when you say manager in the cluster, it is not leader. So manager is nothing but another machine which has the ability to become leader in case if the current leader is not available. Okay, so just like your TL. So that is where, how do you differentiate it? So again, it is in the status. So now if you take any of the worker and you promote that worker to act as a manager when it is needed, then the status of that manager or that machine will be reachable. So reachable meaning is, at any point of a time, this machine can become a manager if the leader is not available. Okay, so that is how, when you're trying to create a cluster, we need to understand that you cannot always have one manager, because if it goes down, you should have a person who can take charge, just like your team, right? The same way, in the cluster, you are going to have one leader, but if this machine is not there, is there any machine which can take care? So for that, you need to have couple of reachable machines. Okay, so that is how you will be making high availability, so that if this machine goes, then this machine can become the leader. So that is when, in a cluster, you will have one leader and you can have several reachable machines, as well as remaining will be worker. So that is where we have to understand, for us to work, how much of manager machines totally we need and how many workers we need. Okay, now let's assume that if this leader goes down for some reason, then the state of this leader will become unavailable. Then immediately what will happen is, the reachable machine, whatever that you have in the group, will take charge and that will become the leader. So in that case, the status of this machine will get changed from reachable to leader. So that is where now any communication that you are going to do, you will be going to the leader machine and you will be able to do it. And then this machine will start taking care of the cluster. So that is where any normal worker machine can be promoted, which can become a leader later. So that is where, understand, leader is actually one machine, because you cannot have multiple leaders. However, you can have multiple reachable machines which are potentially eligible to become leader later. Now, if you have more than one machine which is reachable, then the swarm will randomly pick any machine which is available and mark it as leader. Okay, now in this case, now when I said that the actual leader went down, this machine become a leader. Now what happens if this machine comes back? That is where this will become reachable. So that is where any point of time you cannot have two leaders, right? So now what will Swarm do is, okay, anyway I have a leader, so you become reachable. So that way, now at any point of time, only one leader will be there and the other will be reachable. Okay, so this is where we will see how we can promote a machine to become a reachable, and then if it goes down, how will it become a leader? Okay, then now in the regular concept, when you have machines, regardless of whether it is manager or leader or worker, when you try to create a service, it will create the task, which is nothing but container, in each and every machine. Okay, so that is where in the first example, when I did a service create, it created it on the same manager or leader. But what happens in real time is, as you go in a team also, if a task has to be done, the manager's responsibility is majorly to manage everything. It's not like nowadays, yeah, managers are requested to code, but on a major side, now he's not going to sit and code throughout the day. So you have to ask any of the other employees or do the testing, wherein he can also do, but typically not too much. But in general, the reason behind that is, if you are going to ask him to do all the work, then he will not be able to focus on the management part. The same way, when you take a group, you are not supposed to run the containers on the leader, because if you start running the containers, the leader will get loaded, and then if something goes wrong and the leader goes down, then it will be a problem for us. So that is where the best practice what we have to do is make sure we do not run containers on leader. So how do we do? So that is where, whether it is leader or any machine, for some purpose, if you do not want the Swarm to allocate containers to that machine or create, then we have a new status called drain. So in addition to this, if you set up drain, and then when the Swarm is running, automatically it will see that, okay, I will not allow any containers to be created. In that way, it will be using only those machines in which the status is available. Okay, so that is how, when you're creating a cluster, what we need to do is, we need to first find out how many reachable machines you need, and in that promote the respective workers, and after that, in which machine, that is your leader machine, if you do not want containers to be created, then you can go ahead and set up drain. Okay, so that's what we are going to do now. Okay, so to do that, we will be using further the docker node command. Okay, so first let's go back now and see the output. So now if you look at, you can see in this output the manager column, and you can say leader. So that way, whatever is blank, that is called as worker. So that is where my first machine is manager and all the remaining machines are worker machines. Okay, so now if I want to make one of the machine or promote one of the machine to be a reachable machine, then you can simply say node promote, and when you're saying node promote, you need to give the particular machine name, and then you're going to promote it. Okay, so when you run, it will ask you for the node name. So you can go ahead and say node promote. So let's say that I am in favor of this person. Okay, let's say like I like this person in the team, just like that, I'll take this machine. So now if you go ahead, you can see this machine has been promoted to a manager, but technically in the group we are going to call it as reachable. So now what happens, at any point of time, if this machine goes down, the other machine has the potential to become the manager immediately. So like this, we always follow a group, and in that you need to decide how many managers is needed. So for simple purpose, every time you need to make sure at least you are going to have n-1/2 number of machines. So that way minimum of 3 machines is what you're going to manage. Okay, so that way as you go into a real cluster, you will be having many machines. To make sure effectively you are able to utilize them as the managers, you need to have minimum of 3 managers. Okay, so now here let me promote another machine. So let's take this machine. So now here I'm just promoting it as a machine. So if you go ahead and say node ls, you can see now these 2 machines are worker machines, but from that they got promoted as a manager. However, both have the potential so that the swarm can randomly pick any one of them if this machine goes down. And in that, if I create a container, still it will create, because that is where I need to set up the drain. If I don't set up the drain, then what will happen? It will be picking up any machine randomly. So before we see the drain, now first let's see if one machine goes down, how it will make sure that this leader will be replaced with another machine. Okay, so we don't have any service running and we have this node. So what I'll do now, this is the second 104. Okay, so let's take this machine. So this is the machine which is acting as a reachable. Okay, so now what we will do, we'll try to reboot this machine. Now as soon as you try to reboot, now the status would have changed. Now let's go and find out which machine is okay. If you try to run this command called node ls, it will be available only if it is a manager machine, because you cannot run this from any other machine. So that where you can see the first available machine is this, and this become the leader. Okay, whereas the other machines is reachable and this is unreachable. So that is how whatever that you are going to create, it will be created on this. So that's where you can make sure that your cluster is highly available. And not just that, if a machine goes down, it will try to replace the containers also in that. But before that, now whatever I want to work, I can create my service from this. So if I say docker service create, okay, name, and now in the beginning, if I want to create 3 containers, so that's where let me go ahead and say this command, because earlier what did we do? We created 1 container, but while creating itself, you can say replicas, and this will take 3 containers depending on the need what you have given. Okay, so that's how you can try to manage. So in this, okay, 46, right, this one. So here, if I say this, you can see it's going to create 3 containers, 3 replicas, and now depending on whatever machine is available, it will be creating it. So docker service ls, so there is 3, and if you want to see where they are running, you can see it's running on these machines. But however, like I said, it is also running on the current manager itself or the leader. So now if I don't want this to execute, then what I'm going to do? So that's when you can use the drain option. So you can go ahead and say docker node update and availability is drain. So this way what it will do, it will try to make sure that whatever the machine that you are taking, it will not create container. Okay, so now quickly if I say docker node ls, you can see even though it is leader, availability is drain. So the meaning of that is swarm will not use this for creating container. So by saying that, we already had 1 container running, correct? So now if I said drained, the meaning of that is immediately it would have deleted this container. But what is the swarm doing? It needs to maintain the service. So that is where, let's quickly clear and go back. And if I say node, or sorry, service ls, you can see the 3 is available. How is it possible? So that's when the swarm, if you go back deeper and see, this was the container which was first created in this, but since you said drain, it made sure to delete it, and because it is deleted, now the replica became 2. So what you wanted was 3. So to make sure that it is available as 3, Swarm would have immediately found out which machine is available, and in that machine it would have created the container. So that is how Swarm, it doesn't just create, it also monitors, and at any point of time it will maintain the state, which is very, very important. Okay, so without we doing it, it will be able to do. Okay, again, when you are working, like I said, without a worker you cannot have, right? So you cannot have a team with only one manager and no one else. So obviously you need someone to work under him. That is why we are calling him as a manager. If not, I will call them directly as a worker. So now if you do not have a worker and you just want to do, the meaning of that is you have only one machine. Then you don't need a swarm mode. You can just work on the default standalone mode. Okay, so the same logic over here. So make sure that when you're creating a cluster, yes, minimum you should have one worker. Okay, so this is where how we saw that we can set up which one can be manager and which one can be worker. How do you promote a machine to become a suitable manager and a leader little later when the actual leader is not available? And how do you set the status as drain so that you will not be able to create containers on a particular machine or on a manager? Because this is quite useful. Sometimes, let's say, containers are not getting created in one machine because of some problem. Now you want to debug it, because while you're debugging it, if you are still added the same machine into the cluster, Swarm can create any other container for any other service in that machine. So in that time, you can just make sure that instead of removing it from the cluster, you can just say drain, so that Swarm will not allocate any machine, but it will be still in the group. So that is how you can use it for debugging. But this is what we are going to use it for managers, to make sure that it doesn't get loaded. Okay, so that's the logic of managing the nodes and setting up your actual cluster with your needed amount of managers, leader, and workers. Okay, so that's whole of the basic logic. So now let's understand with this what are the other things we have. So ideally, it is again not that you are going to create a service and number of containers only once. Now, based on your need, in the beginning I was telling you, I might be requiring to update, correct? So that is where now if I want to give a build for QA, I would have generated, and now I wanted to deploy, I can just use a swarm and say create a service, and it will be creating whatever containers that I want. And now if I want to deploy a new image, then I can just go ahead and update the existing service. So I don't have to keep on creating a new service. For the same service, you can update. You can update the image name, or you can also update the number of replicas. Okay, now again, directly updating the replicas is what we call it as scale. So in that way, if you want to update an image for the same service, you're going to use Docker service update image, and then the name of the image what you want, and against which service that you want to run. Now, so this is where now I'll say Docker service update. So if you take it, we were using Nginx latest. Now instead of that, let me just take up another version of Nginx just to show you this example. So I'm taking specifically 1.17, and then the name of the service is web. So if you go ahead and just run, watch what happens. The same service will get updated. So all the other properties or other details about your state is not getting changed. The only thing it is going to update in your services, instead of the old image, it is going to take the new image. In that way, you have told 3 containers or 3 replicas, it's going to maintain the same 3. So now if you say ls, you can see it is maintained, but it replaced. So this is how the existing containers will be replaced. Okay, and once again, if you go ahead and say ps web, you can now see these are the previous one where it has replaced, and instead of using the nginx latest, okay, you can see now it has created it with new. So that is where it is tracking everything separately, so that you will be able to see where exactly it is running, and then which machine, and then what is the image, all those things. Again, if you want the properties of this task, you can use docker inspect. So this is how you will be able to update an existing service, which is what we call it as rolling update. Without affecting your service, quickly you can go ahead and deploy new builds. Now, when you are trying to do update, sometimes what happens is there might be an issue. That is where, for some reason, let's say the image is corrupted, and when you are trying to deploy, it would have stopped the previous containers, and it would be trying to create 3 new containers. Now, if these 3 new containers are not coming up, then what will happen? So that's when every deployment should also have a rollback. So that's where you can do rollback in 2 ways. That is, when you are trying to say update, at that time you can say a failure action is rollback. That means if you're trying to update some content like this, at that point of time, if something goes wrong, don't create containers on the new change. Instead, whatever was the earlier state, you go and take it up. So that's where you can do one rollback, or separately you can just say docker service update rollback. So here you are not adding any more properties, you are just trying to tell whatever was the previous state. Okay, so now watch this. So if I say rollback in web, what is it doing? So it is maintaining whatever the state that we had earlier. So we had told 3 replicas, so it is maintaining the same 3 replicas, and then in that 3 replicas, now what is the image that we had told? That is nginx latest. So if you go back and now do a docker service ls, you can see it would have taken this back. So that's how your rollback will be very easy if you use orchestration, right? Because imagine many containers and you want to stop and go back exactly to the previous state, it just takes matter of seconds for you to replace everything. So that is how docker is going to help us in doing the deployment in a better way, or this is what we call it as modern way of deploying. So instead of this, if you had to do it manually or traditional method, you need to go find out machine and try to install it, or if something goes wrong, you need to go to each machine separately and then stop your application and then delete it or remove, because rollback will be again a tedious process. Whereas here, rollback is nothing but stopping that container and deleting and recreate the container from your old one. But for this, your regular docker daemon will not help because it doesn't have all this feature. So that is where by doing orchestration, you will be able to do the deployment better. Okay, so that's where your deployments can be easier and be managed effectively using orchestration. In that, you can see how easy, if you have many containers to just recreate, it will be easy to be rolled back. So that's how when you're deploying in real time, it will be quite efficient. Okay, so what we saw is rolling update.
Adam, here, what is the update failure action? Can you please explain the command?
See, now I didn't do any other update. I just rolled back to the previous state. But assume that when I'm running this command, if this image was not able to deploy, or we were not able to create containers because of this image, then it will not do anything. It will be just retrying. At that time, if I add this option called update failure action is rollback, that means when you are trying to update some image, if this doesn't work out, then go back to the previous state, whatever you had. That is what the meaning.
So automatically it will be done, right?
Yes, you don't have to do the rollback. This command will be internally done by this if you add the option.
Got it. Thanks.
Okay, fine. Now I'm just trying to go through one by one. So now when you're trying to run the containers, now if you have actually looked at it, there is a word called replicated. So what is the meaning of this? So what happens is when you are trying to create containers, you want to create based on the replicas count that you want to have. Suppose if I say, hey service, I want to have 2 replicas, or scale it to 2 or 3. Here you are defining it. So that way the duty of the swarm is maintain the state on how many exact replicas that you want. So that is where, and the service by default it will be running in a mode called replicated mode. So what do you mean by replicated mode is how many replicas that you wanted, exactly that much of replicas is what it is going to maintain. So that is the default one. Now what is that we are trying to learn here is there is another mode called global mode. Now the difference here is when you want to run a service in a global mode, you are not going to tell how many containers you want. Instead, the meaning of global is if you say create a service and run in global, by default, so far we saw that if I don't tell any replica, it will create one. But when you run it in global mode, the meaning of global is I want a replica of this service to be running on all the worker machines which is available in the node. So that way, when you say run a service in global mode, it will try to run one replica on all the machines. So now if you have 10 worker, then in each worker, one replica will be running on the service. So now if you go back and say service ls, then it will show 10. So if you have 5 machines, and if you are running a service as a global mode, then it will be running 5 replicas. So that way the service will show 5 replica. So the meaning of this is if you want one replica to be available on all the worker machines, then use global. But why do I need this? So think if you're actually having an application which needs to be executed on all the worker, may not be your direct application to use, but for your operations work, right? Now let's say, I believe everyone knows what is log stash. I want to read some log from a particular location in the machine. I can have an agent of log stash that will try to get the data. Now, if I want to install and run logstash on all the machines, instead of me doing it, I can have an image which has logstash and then create a service in a global mode. Then what it will do? It will make sure the container for your service is running on each and every machine. So that is where any kind of monitoring that you want to do, and if you want to run some agent in each and every machine of your cluster, you can simply go ahead and run it in your global mode. So the service will make sure that each and every machine has the copy of it. So that way, in this, you are not going to tell how many copies you want. Instead, for every machine available in your group or cluster, there will be one copy of the service created. Okay, suppose if you are trying to add a new machine to the cluster, then in that also automatically this will get created because it now keeps the count of machine. Oh, someone added a new machine, that means there is a new count, then let me create a replica on that, and vice versa, which means if you remove a machine, automatically nothing will be there on it. So okay, so that is where think on a regular deployment, if you want to test your application for development or QA or other work, you will not be using the global mode. But for operation work other than your product or application, you need to install some kind of agent which should be available on every machine. Then you can think of using it in the global mode. Okay, so to show you now, let's me delete it. Okay, so now see what happens. We will say Docker service, and in this, the only thing that I'm saying is name is web, but additionally mode is global, because if you do not tell the mode, it'll always go into the replicated. So now, how many machines do I have in my cluster? Typically, I had 4 machines, but out of that, one was not available. But now let's see how much is available. So Docker node ls. So you can see this is still unreachable. That is fine. But remaining is 3. But in the 3, there is one machine which is drained. That means it is not supposed to run. So that way, there are only 2 machines available. So automatically, um, okay, I'm sorry, I just got a call. So by using a global mode, for every machine available, you will be able to create a container, okay, which is nothing but a replica. And okay, so that's what we call it as replicated or global mode. Now, another important point. So if you go back to again Docker Compose, I told you if you have a microservice architecture, then for one image, you can say 2 containers, 4 containers, 5 containers, 6 or whatever. But what if you have 2 separate images, and for both of them, you need to separately create multiple containers? So that is where, similar to how we were able to do in the Docker Compose by defining a file, that is Docker Compose, in Swarm also, we can create a file called Docker Compose. And in that, you can define one service or multiple service. But if you have multiple services or a service that you want to call through a file, then there is one more layer on top of service which is called as stack. Or in simple way, stack is nothing but collection of service, wherein a stack should have minimum of one service. So that is where initially I was telling you about imperative and declarative, right? So far whatever we did was imperative. Now if I want to do the same thing, I can create a Docker Compose file, and it will be easy for us to maintain everything. Because in real time, if you want to do a deployment, I cannot keep running the commands. Instead, I can write everything in a file, and I can automate it in such a way the file can be applied. So that is where, if you want to use the compose file, then you are going to use something called as a stack. So stack is nothing but collection of services. So this is where the same logic what we used for the Docker Compose there, we are also going to use the same way. Okay, so this is a simple example where whatever that we did so far, I'm trying to do the same thing using a YAML file, which is Docker Compose. So you can see here I'm defining it as what version of my Compose to use, and in that, what are the services. So again, I'm just creating one service called as demo web, and what image to use, what port number, and what volumes to map. And in that, you can choose what kind of mode that you want. So that is where you are going to use a new keyword called as deploy, and under that, what is the mode you want. If you do not tell the mode, then by default it will be on the replicated. However, here if you say mode is global, then it will be creating one copy of this on all the machines that we have. And further, the next one is replica. If you do not tell this, then it will create one replica by default. However, you can change it here. Okay, so let's quickly try to use this.
Quick question here. Can we, when we set the mode to global, do we need to update the replica as well?
When you are saying global, the meaning is you are not fixing replica. For every machine available in the cluster, the swarm will create a replica.
All right.
Okay, so now I have created a compose file with the same. So now if I want to execute it, I can just go ahead and say docker stack deploy -c the compose file, and then whatever the name of the service that you want to manage. Okay, so here I will just say docker compose. Now this is where it's not mandatory you should use, because you are passing the name. So even you can have any name, but it should end as a YAML file, and the format or the syntax should be a YAML file. Now I can do the same thing over here. So you can see that whatever that you have to do manually, it is very easy, because as we go through, there will be a lot of other options. So again, it will be difficult for us to use the imperative way. Instead of that, you can go ahead and run. But the only difference now is if you have multiple services, that is also easy to put everything in a single file. Okay, so that's how, if it is a microservice, then I can define it as different service one by one, and if I run it, it is going to take care of everything together. And now additionally, you can see there is something called as a stack. But as you move forward, it's the same. Now if I want to see what exactly is running, I can say docker service ls, and internally, see, this is the name of your stack now, not the service. And this stack is creating one service, and this is the name or the ID of your service, wherein you can do a ps, and you can see inside it there are two particular replicas. So that is how in real time you are not going to use the imperative command. It's more about using the compose, because when you do your CI/CD or when you are trying to do your deployment, it's always easier wherein you can just specify the YAML file, and in that you can just typically tell what are the different configurations that you need, and based on that it is going to just bring it up. And that way, if I want to update, rather than me going and running the command, I can just go ahead and execute by updating this file, then it will be easy for us. Okay, so it's the same, but the only difference is you are going to run everything through the stack, that is nothing but your YAML file. Again, if I want to just remove, I can just go ahead and say rm and the name, and ideally it will remove the service, and the service will remove all your tasks or containers. Okay, so that's the only difference. It's not much, but it's the same what you're going to do, but in a YAML file. Okay, okay, now again, this is what we were trying to see, because if at any point of time your responsibility of the swarm is not to just create but also to monitor, so that if a particular container in a service goes down, it will try to replace. So let's say that I had two containers. Now once the service is created, if one of the container goes down, then the state what we would have told is 2. So what does the service do? The swarm will make sure that it needs to maintain the same state. So then it will go and find out whatever the machine is available, and it will try to create a container for that. Okay, so let me show you that. So right now let's do the stack deploy, and we'll see the same. So I'm saying we need, okay, so we have told we need 2 replicas, correct? And then here, if you say this, and you can see it is running on these 2 machines. So let me just go to one of the machine. Okay, And let's take this machine. I'll just quickly reconnect. Okay, so you can see that there is a container running in this machine. Okay, the ID is 1DF8. So in this, if you try to say docker inspect, okay, and then if you can just grep, okay, so you can see 1DF, this is the one running, correct? So for some reason, if it gets deleted, or what I will do, I'll just forcibly stop it just to show you. So now there is nothing running. So quickly, if you come back and if you try to say ls, you can see it is available. How is it possible? So quickly, what Swarm would have done is it would have maintained. So that is where to replace, it has created another container probably in the same machine, right? But if you have more machines, then it can choose any machine which is available. So that is how services is going to work. It's not just to create the container, but to monitor and make sure that the state is always maintained. Okay, so that's whole logic of service. Now, there's another important point is, okay, we were talking about load balancing in the beginning. How is it going to help us in the load balancing? Because what happens is now, let's assume I'm creating a service, and in that service, I'm saying, let's say Nginx, and I'm saying I need a container which will have port 80 exposed. And if I say 3 replicas, then what will happen? Each one of them, whatever the container is going to come, as we know that, we are going to do a port mapping to the host machine. So that is where now, if you try to access them, then the container will be accessed to the host machine. That is how we saw in a regular method or in the normal standalone method in the container management sessions. You create a container, you map the port to that particular machine, and then you went and you wanted to access, then you should know the IP of this machine or this machine. But what happens now when I have more than one containers in which the same port is available and it has been mapped to one machine? Now, if I want to do load balancing, that is where internally, if you understand, all these port which is running on the host machine will be tied up to the Swarm cluster. So that way, now you don't have to access them using the IP of the machine. Instead, you can go to the Swarm and access. If not, you go and access any machine. This will do a round robin based connection, which means what I'm trying to tell you now is, if you have 3 containers based on 3 machines. Now, if you want to do load balancing, you can go to any machine, and if you try to connect to 80, it will not always go to this machine. It will be doing a round robin. That way, first time when you connect to this machine, it will connect to this, let's assume. The second time you connect, it might go to this machine on this port, and the next time you connect, it might go here, and the fourth time some connection is coming, again it might come. That is because the port, whatever you are mapping to a host machine in the cluster, will be available entirely in the Swarm. So that is where, regardless of where your port is available or in which machine it is available, from any machine you can access. So that is where you can take one particular machine's IP and you can connect to any of them. But however, in real time, what happens? I can't remember the IP of each one of them. So that is where you can have one more external load balancer that will be mapped to the IP of any of the machine. So that is where from outside, when you are going to create a VIP and access, that will connect to any one of the machine. And if you connect to any one of the machine, you can access all the port numbers available in your Swarm. So that's what happens in reality, okay? Because rather than we going to each machine, we can take any one of the IP of the machine and I will be able to access it, okay? So let me show you that quickly. So here, now we have two, right? Now let us try to bring this down. Now I'll again go to Docker Compose. So let's change the replicas to 1, and we'll say the same stack deploy. So it will just get updated. Okay. And now if you go to ls, okay, you can see it updated. Guys, please mute. So now you can see there is only one running, and it is running on machine 14, right? So typically if you say machine 14, which is nothing but my second machine. So in real time, if you wanted to access, you should go to the second machine, okay? And I can take, okay, let it refresh. Okay, so I can take this. Now, this is what you think that it is going to work. Okay, it's just, what did I do? Probably, let's not, it's not working. Okay, let's quickly take our old example. Let me remove this. Okay, now how do I create? Now this is where, let's go back to the first one. We'll say create. I'm just quickly creating in the regular way. So it's running, and it's running on 104, but still, if it's running properly, I can go to any machine, and you can see I'm accessing. This is not the same machine, so I can still access. Now, if I want, I can also access it from the first machine or second machine or the fourth machine. If I want, I can go to the fourth machine. Even over here, it's a different machine. I can just go here, and it will access. That is because it is working in a SWAM mode. So the meaning of the SWAM is not just that you will be able to access them, but typically what happens is it does the internal load balancing using ingress, in which whatever the port which is mapped to the host machine is also mapped to the SWAM. So that is where, think of it in this way, that if you want to access it, you can go to any machine and access the port. It will be able to reach you through the SWAM. So that is where internally it does the load balancing, and that also it does in a round robin way. But however, now it's not going to be so easy. So that is where we are going to have one more load balancer on top of that, and that is our external load balancer, which we will be mapping to each machine. So that if I want to reach a port 80 in my load balancer, I would have mapped so that whatever machine is available, the external load balancer will go to any of the available machine, and in that it will access 80, and that will connect to the actual 80 which could be running on any machine. So that is where in real time, when we have to access an application, we don't have to remember on what is the IP of the container or the IP of the machine. Okay, so that is how SWAM will be able to help us to do the load balancing. Okay, now just because of time, I just have a couple of things, so I'll be a little fast. So now, so we have been seeing different concepts. Now let's step back into another concept for Docker image creation. So let's say for every build, I am trying to generate an image, which will be my final product image. So for that, what is that we are going to do? So I'm going to take a base image and then put whatever the layers that we want, that is could be a particular OS, and then whatever the build that you have generated, that plus for an application to run, you might also need some configuration file, right? So now if a developer is trying to create, or as part of your CI/CD, whenever a developer checks in, you have to do a unit test and a smoke test. For that, you need to connect to a dev database. Now let's assume I have created an image in which I need some configuration file which has the details of my database related to dev. Now, if I create an image like this, if you understand, image will not be changed because it is the same build or the application that is available, which we are going to share it across all the environments. So that is where the problem that happens is, whenever you are creating an image, you cannot put the content which is different for different environment. That means you are supposed to create the image only with common things that you can share across environment. And especially like this, when you have some configuration file, I need the file, but the content will vary from environment to environment. So how are you going to do? So that is where, as part of your image creation, you need to separate all these configuration files and give it during runtime. Then what will happen? Think of having your image only with your actual application and configurations without it, so that when you try to create a container for any of the environment, it is the same application, but the only thing is you are going to give your runtime file. Okay, so that is what the standard that we follow. But what is the problem in that we are trying to solve? So now imagine this way. In QA, we have 4 machines and I need 4 containers, or let's say I need only 2 containers. Now, when I am bringing up my container, I want to pass a file to it. So how are we going to do? So this is when you might think of 2 options. One is either you can create an environment variable which will have the entire content of the file. But if I have a bigger file, then my environment variable will not be a right option. The second thing that you can do is think of having a volume, so that in each of my actual machine, I can create a volume in which I will put a file, so that when a container comes into that machine, then what happens? I will be mapping, or when I create a container, I should map it to the folder which I am sharing it from my host machine. The problem over here is, if you want to update this configuration file, then in each and every machine, you need to make sure that this file is available and this folder is able to share. So that is where that will not be an ideal solution, because tomorrow to your cluster, you are adding another machine. In that machine also, you need to copy this configuration file and make sure the volume will be accessible, right? Now that's when you don't know on which machine Swarm will be creating the container. So that is where, instead of using the volume method on putting the files on the host machine, or instead of using it as an environment variable, there is a concept called Docker config. Okay, so what do you mean by Docker config? So the simple meaning of that is, you can store whatever the files that you want to pass as a configuration, which is nothing but a text file, not a binary file. Remember, because we have a file size limitation on how much you can store it. So that way, instead of storing a file in each of the machine, you can store as a config in the cluster. Okay, so what it will do, during runtime, you can try to take that and put into the container automatically. So that way, where it is going to be stored, it is not going to be stored on any of the machine. It is going to be stored into the temporary memory of the cluster. Okay, so that way, now whenever you are trying to bring a deployment or a application for deployment through Docker, you will have the image which will have all the standard files, but anything as a configuration file that will be changing during runtime, like your parameters for database, or some parameters for debug mode, or some startup options like JVM, like heap memory that you're going to tell. All those things you can pass it through a file. But the problem here is we don't know in which machine it is going to come. That is where in the SWAM, what you will do is you will tell to create as a config, and to that you tell the file, so that it will be storing it in the virtual or the temporary memory of the SWAM. And during runtime, when you try to define your state, you can tell which is the file that you have stored in the SWAM, and when you take this file, where do you want it to appear inside your container. So that is how you can do the mapping. So by this, what will happen automatically, when you have to create, first make sure in your SWAM you are creating something called as a config, and to that tell what file you want to create. And then when you are creating your service, you can tell, hey, this service should refer to this config wherein it has internally this file. And when you try to use it, where it should be available inside the container, that location also you can give. So that is when you have to first create the config and then tell the SWAM in the state what is the name of the config and where this file should be put. So that way, regardless of wherever this container is getting created or which machine it is getting created, in all the containers automatically the file will be available. So that is where you don't have to worry about copying the file to all the machine. Just go to the master or the manager machine, and in the manager you create something as a config by passing the particular file name. Okay, so again, you can do it in two ways. You can either do it through command line, or you can give the same using the Docker Compose. However, remember, when you are trying to use this config inside your container, if you don't tell where it should be putting it, then by default it will be going inside the / folder on your Linux. And if you tell a location, then typically it will be going into that location. Okay, so just to show you quickly, let me try to use this command line. Now we have to do a docker config create and config name. So for this, what I will do, I'll go to the manager, and here let me just create a simple file. Okay, so I've just created a file here called sample.conf, and all it has is this. Let's not worry about the content. So here we will say docker config create, and then you are going to say what is your config name and the file. So let's say I will call it as test config, and then what file. So by doing it, now this file will be available under a config option on all the machines by default. So if you want to see, you can just say docker config ls. You can see that there is one config which has ID, but internally it has the content of this file. So now all I have to do is, when I'm trying to create a container, I need to tell which config to use and in which location I should be putting it up. Okay, so that way, I'm sorry. So that way, if I go back, I can just take this command. Let's try to run this. So now here, I'm saying docker service create and the name of my service. Okay, let me go to the same web and then config. Now this is where I'm telling what is my source. So I've created a new config, and this where I want to put it. So inside my container, I want to put it under a folder. Let's say I will say temp. So under temp, I want to put this file with whatever name I want, and we are going to have my port mapping, and from this whatever the image that you want to have. So the same thing whatever we did, additionally we have added this. So now regardless of where the container is creating and how many containers are getting created, it will make sure that in all the containers for this particular service, under the temp folder you will see a file called sample.conf, which is nothing but what we just now created. So here I'm not telling any replica. So by default, it will create only one replica. Okay. So Docker service ls. Okay. So let's quickly remove this. Okay. Now let's run. Okay. So let's see where it is running. Okay, it's running on 18. So that's this is the machine, I believe. Let's cross check. Not this. Yeah, this is the machine. So the container is running on this machine. Okay, now if I just say docker exe container and ls temp folder, you can see this file is available. And if I cat this file, so you can see that the file is available. Okay, so the meaning here is, rather than you creating this file and make it available on all the machines, just go to the swarm, and in the swarm you create as a config and tell the file name, and inside the container all you are going to do is refer to that. So that way you're going to tell what is your configuration file and where exactly it has to be available, so that regardless of where the container is going to get created, it will be available. And not just this, if the container gets deleted and a new container is created, in that also the state you have defined, so automatically this will be available on the new container in the same location. So that is how it will be very easy for us to pass whatever the configuration files that we need for our applications deployment. Okay, so that's what we call it as Docker config. Now the same, if you want to achieve it through a compose file, then this is how you're going to define, wherein you're going to define the source and the target. And typically in this external true means we have first created the config before running the stack command. In that way you're going to mention it as true. Okay, so again, if you run whatever that we did manually, that was more of an imperative command, the same thing you can run it through your Docker compose. Okay, now just because of time, I'm just trying to skip this because there's only one last option that we need to see, which is again health check. Okay, now all this what we were seeing is how do you create container, where it should get created, how to access them, or in fact if you want to pass a configuration without you worrying where is the container created, you can pass the configuration. That is what we were seeing. But now going back to the orchestration's need, how do you make sure if the container is not running, Swarm will take care, because it knows that the state, based on the state, it will try to make sure the same number of containers are created. But how do you ensure within the container, whatever the application or your command, whatever you're running, is it running fine or not? So that is where we need something called as a health check, wherein health check is nothing but an option where for a service, each and every container that it is running, you can tell the swarm to run some kind of command or script based on your need, and the swarm can run it on each and every container of your service. So that way all you have to do is, okay, what is your service, and for that service what is the health check that you want to do, and that you can give it as a script or a command. And then if you tell that to run it to service, and then what happens when the service is created, Swarm will not just make sure that the service is running or the number of replicas is available, it will also make sure that inside it the command whatever you have given as a health check is also going to run. So that is where if the health check command or script doesn't run properly, or in very simple, if the health check command or script whatever you have given returns a non-zero value, then Swarm will consider that the container has some problem. Then it will try to stop the container, delete the container, and as soon as it deletes, it has to replace it with a new container to maintain the state. So that's how it will be monitoring. So using the help of Healthcheck, we can ensure that it's not just the number of containers or matching your requirement, but every container is running properly. That's what you need. Okay, so that option is what we call it as health check. Now there are several ways that you can do health check. Now few people, while you're creating your Docker image, you can add one of the instruction called health check, but this will not be an ideal place because for some reason, what if you want to disable it when a service is running? Then you cannot do. So that is where you can think of using your compose file, wherein you can specify your health check. Now in this, if you look, I'm used the same default configuration, but the most important one that you have to look at is this part, wherein the health check keyword is nothing but I'm telling for whatever the service you are creating, what is that health check you want to run. So that way, the test is nothing but the name. You can give any string to it. It doesn't matter because I am telling this is what I want to do as a test. Okay, followed by what is the command that you want to run. So this is where, depending on what application you have inside the container, you would be knowing what is the command you have to run, so that whatever command you are running here, that is what the Swarm will run, and it will check whether it exited with a 0 or a non-zero. So if that command exits 0, then Swarm will know that, okay, your application or container is good. And if it returns a non-zero, then it will consider it as a failure. But the question comes is how frequently it should run. So that is where for health check, you are going to tell something called as interval, wherein interval is nothing but when your service is running any number of containers as you defined, inside each container, how frequently should it run this command, whatever you have given, or the script. So that is what is in this example 10 seconds means when I run this, I will get 2 containers. Inside each container, every 10 seconds, I want Swarm to run this. Okay. Then what happens if this command itself gets hung? Because if an application is not running and container is not responding, then whatever the command you are testing or script testing might also get hung. So that is where you can say a timeout, which will tell you that if this command or script, whatever you are running, if it is going to take 10 seconds, then consider there is a problem, then forcibly stop it. So that way you can tell a timeout and retry. Now this is where, for various reasons, if network is not fine, sometime it might not respond. So that is where at the first time itself, if it is giving me a non-zero, I don't want to consider it as a bad. So that is where I can give couple of retries. So depending on your need, you can give, so that the default retry is 3. So now what happens? Every 10 seconds, it is going to run that command, and consecutively, if the first 3 times fails, only then it will be marking the container as failed, and it will try to replace that with a new container. Okay. And the final and the most important one is start period. Now, what do you understand by start period? Pay close attention. When I am bringing up my application, I am trying to tell to run this. Now, what happens? Let's assume I have started my container using service, or when I say service create, it will create container. Now inside the container, every 10 seconds, it is going to run this command. Now, what if my application is taking 40 seconds to start? Then what will happen? Whatever the command I'm running, every 10 seconds, it is going to definitely fail, right? Then you should not be running the health check as soon as the container is created. So that is where you should know the logic, that is how much of time your application is taking to start up. So based on that, you can give the start period. So in my example, if I know my application is going to take, let's say 1 minute, then my start period should be 60 seconds. That means only after 60 seconds of the container coming up, we will be able to start running this interval, that is from the 70th second, for every 10 seconds it is going to run the health check. Okay, so remember that is very important. So quickly, just to show you this. Okay, now you can just go ahead and say docker stack deploy -c and your YAML. So this way I just want this YAML, and I'll just say test web. So it creates. Okay, but now, okay, let's not worry. Looks like the service is already running. That's the problem. Okay, so docker service rm web. Let's delete it, and docker stack ls, it's not created. Okay, let's go ahead and run. All right, so if you try to say docker service ls, what happens is it takes time. Now, unless and until the first execution of your health check is not completed, it will not show the replicas, because now you can see it says 0. Okay, but if you go inside and say docker service ps, and here containers are there, but why is it not showing it? Because only when the health check is successful you can see. Now, for any reason, if the health check is failing, then it is going to start marking it as failure. Okay, now quickly, if I want to change this, instead of ls, okay, I'll just give a command called no such command. Now I know there is no such command, but when you run it, obviously it has to fail, correct? So what we will do, we'll quickly update our stack. Okay, and now if you watch, it will try to wait for the first 10 seconds, and after that it's going to mark it as failure because it's not going to come up. Okay, it will not come because it will try to restart it for the failure whatever you're going to have. So automatically it retries and it is going to fail, and if you wait, this is also going to get failed. So this is how you can go ahead and try to check what exactly it is running. Docker inspect. I'm doing mistakes. So in this, you will be able to see what exactly is the health check that it is running. Okay, all the properties of that you will be able to know. So this way, when you're trying to run health check, make sure that you give the proper interval, and you also go ahead and say from when it should be starting. All right. Anyway, I hope I brushed up a little bit, but hope it's clear to everyone. And again, thanks for attending. Any questions now?